Alrighty, this is worksheet 3. What's the question number?
Number 17, part C.
Okay, so this is a redox reaction. It's not very obvious, but an easy way to spot that is this one is 0. No matter what ion it formed, this one is definitely not going to be 0. Actually, this one is -1 because our potassium is group 1 metal, potassium, group 1 metal. So it only has positive one, right?
So what does redox mean?
Redox means reduction and oxidation. Okay, which whenever you have an increasing of oxidation state, what's that? It's also our lecture notes. When you have increasing oxidation state, like from -1 to 0, it's like oxidation or reduction.
Okay.
I'm asking, but it's...
Oh, you're asking.
Yeah, so when you have increasing from -1 to 0, is that reduction or oxidation? Choose one.
Oxidation?
Yes. Yeah. So that's how you know which part you're playing around with. Okay. I saw you were talking about, we'll do the easy one here. Manganese, okay, SO4. That's one of the polyatomic anion. You should know the name. If you don't, it's okay. But you should know the whole charge of this is -2. So manganese here is only +2. This one is +2. Okay, how about this one? We just did it today. +7, because each oxygen is -2.
Yeah.
Potassium is +1, so manganese is +7.
Yeah.
Okay, so manganese is gaining electrons. Iodine is iodide, lose electron to form iodine. Okay, so if that's one of the, that's how you know which part you should write. Okay, so ox and re. Okay. Well, write oxidation. Okay. I will write ion first, and after we write the overall, we'll get them back. Okay. Okay. I-, okay, form I2, right? That's oxidation, right? That's what we learned. You might need more space. Well, basically treat this one as a large example, but yeah, you might want to open a new page to write this if you want. Because obviously I'm going to balance the half-half and then write the overall. You can see what I'm doing, right? Yeah. So,
Got it.
all right. Okay, MnO4 minus. And here it just becomes Mn2 plus, right? So before I do anything else, that's it, right? So half-half. Half is because iodine is the one who have an increasing oxidation state, and the only part has this. Yeah. Did you see? I basically only write the part that has the exactly like our lecture notes. That's it. You will be able to see them clearly. After we write the over, we can write other counter ion. Like sulfates, you can see that's obviously being canceled out afterward. If you write net ion equation, which we don't want them to interrupt our balancing. Well, we just do our oxidation state. Are we cool with that?
That's the one you do first?
Yeah. If it's not redox, okay, double replacement or something, you can use your old way of doing that. That will work. But if it's redox, if it's in your way, we just don't touch them because these are just counter ion. It's just like we need them to make the needs charge 0. So we'll deal with them later. But who has changed the oxidation states? Iodine and manganese. That's our main game. Are we good with this?
Yeah.
Okay. Will you be able to do the half based on what we learned?
Yes.
Okay, give it a try. I just want to make sure all